Hey guys, welcome back. Sorry on the humongous delay. Yeah, I've been waiting for some things to arrive, and also I've been saving a bit of cash up just on the side to try and get some of the key components for the battery pack. I'm pretty stoked that a few things have arrived. Firstly, my heating pad. This actually took ages to track down something that was appropriate. So you can see it's a really thin film, which allows me to put it inside the battery pack. And it's really hard to find this in 12 volt. All of it comes in 240 volt or 24 volt AC, but it's pretty hard to find it in 12 volt DC. So the reason I'm chucking this in here is going to be rolling this up the side. You can see there's some tails on there, so that'll live here on both sides of the battery pack, and this keeps my pack from getting too cold. So my BMS will be able to turn this on and off whenever it needs some additional heat. So the BMS will have a loom of sensors all through the battery pack, and that will maintain the temperature above the minimum point which the batteries are happy. So these guys are quite comfortable going down to about 15 degrees Celsius. They will go to 0, but you don't really want to charge them at those super low temperatures, because otherwise you're going to damage the chemistry of the cell. So this guy's going to manage the heating filament film. This took me so long to find. I eventually found it from a company in Europe. Funnily enough, they use it in all kinds of weird applications, greenhouses and heating, like defrost heating of underneath surfaces like threshold steps and things like that in apartment blocks, so you don't get ice on steps. So yeah, pretty cool product, super robust, really well made, really great customer service. Awesome thing about it is completely self-regulating, so you can like cut it at any one of those, between any one of these kind of white strips, and it will only deliver the specific heat output per square meter that it's designed for. So you don't have to worry about resistors or any of that other sort of tricky stuff when it comes to this. It'll just do its own thing. So that's pretty cool. The other massive thing that's come through is my PCBs. Now I mentioned a while ago, so I had these kind of mock-ups that I did out of 3D print. I sort of thought about, oh yeah, cool, these are going to be where the pads are, and did some design, PCB design. Holy shit, I have a huge amount of respect for anyone who does electronics design. My PCBs are incredibly simple compared to something that has surface mounted devices on there. However, it took me a massive amount of time to understand how to use the design software to actually get a product that PCB fab house can manufacture and send to me. So I got these from a company that actually have an office here, where not far from where I live. They're manufactured overseas, but you can see these are going to be the PCBs that go on each end of the battery pack. So you can see there's some method in my madness. So yeah, these guys, obviously they've got a V-groove cut in here, so I can snap them apart, but they'll go on the end. The battery tab will come through this slot in the PCB, and I can fold the battery tab over and put some of this very special compound on the back of there, which helps electrical transfer and stops corrosion. And then what I can do is I can clamp the bus bar on the front, and on the back. I probably showed you in one of the last videos that I posted somewhere in this box of things here. these little strengtheners. So these little dog bones, they go on the back, so they go here, and the bus bar goes on the front, and they actually can help compress the bus bar on the tabs of the battery, so that way they're mechanically held there. I'm not going to even think about soldering the tabs on the battery packs. They're extremely heat susceptible. They do not like being heated. You're very highly likely to damage your battery. All the bit of research that I've done has told me do not apply heat to them. That's why they use spot welders. Spot welders are not going to be enough to get enough surface area to conduct the kind of amperage that I'm pushing out. Almost all of the big car manufacturers laser weld, so they do a consistent laser weld across the tab. I can't afford a laser weld. I can't find anyone that can laser weld here. Everyone's said, hey man, you're crazy. So this is the next best thing. So I've got conductive gold plated PCB on the back, so that's going to help conduct any electricity on the back. These have been tin plated as well, so I'll put some of the special transfer paste on the back, so you've got nice conductive layer on the back, and I'm going to put a bit of the conductive paste under the front, and then the bus bar goes over that with some paste on it as well. So we create this kind of nice conductive sandwich of quite similar metals, and hopefully we don't build any hot spots in there. Electricity is pretty lazy, it likes to follow the path of least resistance, so I'm hoping that the bus bars are going to be the least resistance path. So this is the best method I could think of to be able to build my battery packs. The other really nifty thing about these PCBs is it's pretty hard to see, but I've put little tracks up off each one of these pads, and there's a little pad here ready and it's labelled up, and that's ready to solder all the BMS to. So I'm not having to worry about mixing up BMS wires, and you can see each one of these is numbered and each one of these is numbered. So I've tried to make this moron proof because I'm a moron. I'm likely to make a mistake, and boom, there goes my BMS. So I'm hoping when I get the wiring harness for all the cell taps, I can just solder them straight onto these pads, and then pop them on the battery pack, slip all the tabs through, bend them all over in the right positions. Again, I'm going to have to be super careful because if I bend it one up and one down, yeah, I create a short circuit, and battery pack goes boom. So yeah, so again, tried to make this as kind of like idiot proof as possible for me. It's going to be pretty stressful. I'm actually petrified about putting this battery pack together. I probably shouldn't be because I'm planning what I'm doing. There's a lot of amperage available here. There's a lot of stored energy in these cells, so I'm trying to create a process that is as mistake proof as I can humanly make it. You get tired, you get distracted, kids running or whatever, and you fold one tab the wrong way or whatever. So at least if they're clearly numbered and stuff, I'm able to go, well, hang on a sec, whoops, that tab was supposed to fold that way, not that way, and hopefully I catch myself making a mistake before it's a big mistake, and I've got to run outside with a lithium fire. So yeah, so these are pretty, I'm pretty stoked that these have arrived. It took me absolutely ages to design these and put them together. Yeah, big hats off to people who do PCB design. Big hats off. It's pretty incredible. The other really cool thing about these is it gives me a bit more structural strength as well. So these will keep the pack well reinforced in the vertical direction. And when these are side by side, the bus bars will also reinforce side by side. So the pack will be nice and kind of rigid and not too sloppy. So it won't want to, wiggle and flop around. So that's really cool. So really other really awesome things have arrived. So I've got my super duper heavy duty cable, 35mm cross section. This stuff is absolutely humongous. So that'll carry power from the main fuse and the main battery disconnect to the motor controller. This can easily handle the amount of current I can pull out of this pack. This pack will do 400 amps peak, and it'll do 300 continuous amps, no problem. So we're talking about some serious amounts of juice flowing through those cables, so we've got to have the right size, otherwise we ended up with molten cables and things get very hot. I've also got a couple of samples here of the other cable. So cable management and getting power out of this pack is really tricky. I've had to opt for using 2 smaller cables coming out of the pack. Otherwise I'm going to get too deep with these, this giant cable. If I've got to run that up from the bottom of the battery up to the top, I start to soak up room and start to make my battery pack bigger, and I don't want to do that. It's already massive. It's totally okay to use 2 smaller gauge cables. In fact, 2 of these cables have more cross-sectional area than this cable, and you can see physically this one's nearly as big as that, not quite. So 2 have more cross-sectional area, so in theory 2 of these should carry just as much or if not more current. And what I can do, it's a bit hard for you to see, but you'll see it when I do the assembly, is I can actually bring this one up the middle, and I can bring the other one up here, and I can sneak that in there, and actually it doesn't make my pack any bigger than it already is, which is kind of really nice. And then I can bring all of my BMS harness and whatnot up on the other side, and up the center in behind. So that's really neat. So that took a little bit of thinking to get there. The other one is these lugs. The lugs will be able to go on the back, so they can hide in here, and I can use a cheese head, and then we can come through and bolt with a countersunk cheese head on the other side, which allows me to keep the end of the battery pack pretty flat, which I'll be putting some alumina sheet down, and then direct heat transfer to the outside of the aluminium casing to allow the heat to come out. Funnily enough, pouch cells transfer most of the heat through the tabs. So there you go, you learn something new every day. The other thing is I'm going to be putting some heat pipes down the center of the pack to bring heat out of the center of the pack. I'm really worried about heat generating down in here, and not being able to escape out of this center core of the pack right down here in the middle. So I'm speaking to a heat pipe manufacturer at the moment to manufacture me some flat heat pipes, and then bring them up, bend them over at the top, and put a heat sink on the top as a part of the battery case. So yeah, heaps and heaps and heaps of stuff going on. Super duper excited. There's heaps of really cool stuff that's starting to come together. Huge amount of engineering has gone into just this. It seems kind of stupid, I know. Laugh all you like, it's totally fine. But I'm learning a lot about battery engineering and how to put batteries together along the way. And I'm sure I'm going to make mistakes. That's part of doing your own development work. But hey, you got to break eggs to make omelets sometimes. So yes, I'm hoping to work my way through that. So going to get my heat pipes. They're coming soon. Finally found a manufacturer that's not going to charge me crazy amounts of money for them. This battery pack just cost me an absolute fortune to put together. A lot more than I originally anticipated to do it properly. Heaps of people put them, like solder them and all those sort of stuff, and do it really cheaply. When you look at professional battery manufacturers and they go, hey, I want $15,000 or $20,000 or $25,000 or $30,000 for a high performance battery pack, and you go, holy shit, that's a lot of money. But when you think about all the engineering and actually go to do the engineering, there's a lot in it that I didn't understand coming into it. Idiot. And that I know a lot more now than I did when I first started. So I understand and respect this field a lot more now. yeah, you know, hindsight's 2020, all of that sort of stuff. So anyway, rambling now. So what I'll do is I'm going to wrap that up, and we're going to come back to this probably next video. I'm going to be starting to put together one of these sides. I've got a shitload of work to do to cut all the bus bars, so there's a bit of work in that. I'm not going to probably bore you with that because it's just me cutting and drilling 1,000 holes to suit these holes in there, which is kind of not really interesting watching. Let me know if you want to watch it, but yeah, so I will start to do that in the next video with you guys. So yeah, till then, I'll keep you posted. Cheers.